Hello everyone. So today we are going to discuss here some graph terminology and some special cases as well. So there are terminologies are here. First one, that is undirected graph. In previous lecture we will see what is actually undirected graph. Undirected graph is nothing but an order pair. Okay. So we are having here u and v. U and v in this particular diagram representation, both are the adjacent. Okay, u and v are the neighbors and both are connected with one edge. So u and v are the adjacent of each other with an edge. So E is called the incident. E is called the incident with u and v, because E, that particular edge who is going to connect u and v, is a incident because the particular edge is present there. Okay, and u and v, the vertex u and v, are called as the endpoints. Endpoints because the edge having a two endpoints here. So how you are going to calculate the degree of vertex? So how many edges into your undirected graph, how many edges are coming to that particular vertex, or the number of edges incident on a vertex. So from u, how many edges are coming to you and going from u. So again, whenever you are having a self loop, so self loop is going to consider the 2 degree. Okay, so degree of v is 1 because only one edge is connected to v, and degree of, here is a degree of k is 0 because no one edge is connected to the your k. Okay, that is a pendant vertex. So isolated vertex of v is 0. So how you are going to represent that particular undirected graph? So you are having a 3 graphs, uv and w. Uv, so first edge, that is a uv, then the uw, and the vw, uv and the uw. Okay, so degree of u is 2 because two edges are starts from or coming to the u, so that is a 2. And degree of v is 1 because only one edge is connected, and degree of w is a 1. So here is again one edge connected, and k is having 0 because the vertex is present but no edge is coming or going from to k. So w and v are the pendant because only degree having only 1 degree, and k is isolated. So the pendant vertex is having a degree 1, only 1, and isolated having a 0 degree. Into the directed graph, the edge u and v is adjacent to, or you can say to v and v. So adjacent from u, how many vertices are there? So u is the initial vertex because the edge is starts from u, directed edge are here, and from u, where you are going to reach to the v or to the w. So because v is a terminal, so end point of u is a v because the edge is a directed. So how you are going to calculate? So into the directed graph, 2 points are there, in degree and out degree. In degree in the sense the number of edges for which u is a terminal in the sense the incoming edges to the u, and out degree is u is nothing but initial vertex, means the edges going from your u vertex. So here is a representation, 3 vertex are there, uvw, edges are u, v, uw and vw. So degree of u is 0 because no any edge is coming to u, only 2 edges are going from u. Degree of u is 0, degree of v is 1, okay, and degree of w is 2 because 2 edges are coming to w. Then the some special cases are there. Complete graph in the sense the simple graph that contains exactly one edge between each pair of a distinct vertices. So into the k1, k2, k3, k4 representation of a number of graphs are there. So having a distinct pair of your vertices. Then the cycle. So n is greater than or equals to 3 means having a vertices v1 v2 up to the vn and edges up v1 v2 up to the vn to the v1. So cycle in the sense from first vertices if you are going to start, so again when while traversing you are again coming to the your initial vertices, that is a cycle. And the wheels obtained by additional vertex. Okay, so here in this triangle shape and in this circular square shape, so middle center having a additional vertex, so that is connecting all the vertices. That particular middle vertex is going to connect into the your graph all vertices, so which is known as a wheels. N cubes, so vertices represented by 2n bit string. So two vertices are adjacent if and only if the bit strings that they are represent differ by exactly 1 bit, means here 0 and 1, so differentiation from 0 and 1 is exactly 1, so here 0 0 0 1 1 0 1 1 like that. And then the bipartite graph. So firstly bipartite is a simple graph, and into the bipartite there is only one condition. So from a set v1 to the v2, each and every vertex is should be connected to the other pair, that is from v1 v2 v3 should be connected to v2's all vertices. So here is a simple definition. If we can partition into two disjoint set, that is a v1 and v2, so in that every edge in a graph v1 is connected to the vertex of the v2. So application of that bipartite is we are going to use that bipartite graph to representing the relations. Then the complete bipartite in the sense the vertex set proportion into the two subsets m and n. So here is a m comma n, k 2 comma 3, so upper part and lower part is here. So respectively the all the edges for that k of m into n are connected to the second subset. So into the first example k 2 comma 3 is present here. So two vertices are from to the upper side and three vertices are the lower side. So all the two vertices are the first subset and second subset is a 3. So each and every vertex from first subset is going to connect to the second subset. Then the subgraph, from the your original graph you are going to create a multiple graph, so which is known as a subgraph. So from here G, we are having vertices V, U and W, so we can connect a multiple graph H1. So U, V, W is a first subgraph, then the H2 that is having a H, U and V, that is a second subgraph. So definition of subgraph, a graph is H is equals to V dash E dash, and the where V dash is a subset of V and E dash is a subset of E. Then the another definition is here. So simply subgraph you can say G1 union G2, where E is equals to E1 union E2, so which is nothing but a V1 is equals to V1 union V2. Okay, so into that G1 and G2 are the simple graph or the subgraph of your